So please, I tell you many times, but I want you to remember that it's n minus 1. And in your calculator, it's sx, okay? If it is n, so in your calculator, it is sigma x. You see it? But here we don't use n, but we use n minus 1. So if you use calculator to find the sample variance, so it's sx. Yeah, of course, sx is square root of this number. Next, if I want to estimate p, right, the population proportion, so I will use sample proportion is x over n. What is x? X like is the number of element that have the property x, like have a kind of special gene or maybe have a kind of disease, okay? And n here is the sample size. So you take 1,000 people and you count the number of people that have a kind of property x. So it's x, and x over n is the sample proportion. Okay, and we use this to estimate the population proportion. And after that, you have to construct. I want to ask for the confidence interval. What is the confidence interval, class? I have I is like 90% confidence interval. What does it mean? Of on the mean, for example, on mu, it means that the probability that the population mean belong to my interval, it is 90%. Okay, if I use 95 here, so it's 95%. This number we denote it by gamma. It's the confidence level. Okay, or you can say that in 100 of intervals. So we using this kind sampling technique. So we have 90%. This means that 90 about average 90 on average 90 intervals will consist and mu, right? So probability that mu belong to this interval is 90%. And we consider four cases already, right? Four cases. The first one, if x is normal, right? The first case here, x is normal, and now with the mean is mu, the variance is sigma square. So and sigma here is known. So we have two-sided confidence interval and one-sided confidence interval. For one-sided, we have lower bound, lower confidence bound, and upper confidence bound. For two-sided, we have E is Z alpha over 2 sigma over square root of n. Okay, so sigma over square root of n here, we call it the standard error. Standard error, right? SE. And E here is the error of the interval. So the interval, the confidence interval here, mu belong to the interval x bar minus E to x bar plus E, right? So you can understand it like it is the x bar is here, and it follow normal distribution, and this is our interval. This is x bar minus E, and this is x bar plus E. So the probability that mu belong to my interval, it will be 90% or 95%. Okay. Yes, and the error in estimating here, mu, for example, mu is here. So the error in estimating mu and sigma using x bar here, the error it equals to mu minus x bar absolute value, right? And it always less than or equals to E. So please remember that if we have what is E here, it is the maximum error when we use this interval to estimate mu, right? And the length of this interval, what is that, class? The length of this two-sided interval, it is 2e. Okay, so maybe I say that yes, I want the length of the confidence interval to be 1.5. It means that 2e is equals to 1.5. And the question is, if I give you a specific error, so I give you e here. So how can we find a sample size such that the maximum error is less than or equals to a number e? So class, can you tell me, can you write the formula for n, the sample size? If I give you, so given e, you have to find n. So n is greater than or equals to what? Can you? Hmm? Anyone? Anyone remember? Hmm? No, not remember. You can look at the formula here, right? Sigma over E, no, not that. Yeah, so from this formula, you can see what is n, right? You have that E is less than, so Z alpha over 2 sigma over square root of n is less than or equals to a number. It means that you move square root of n to one side and e to the other side. So square root of n greater than Z alpha over 2 sigma over e, right? So if I give you e here, I want to find n, so you find square. You see? Yeah, so it's Z alpha over 2 sigma over e total square. And please remember that you have to round it up, okay? Because it's greater than or equals to. So you have to round the number up because the sample size must be integer. That's why you have to round it and it round it up. Okay, for one-sided confidence interval, we have E here is Z alpha sigma over square root of n, and the lower bound is x bar minus E. The upper bound is x bar plus E. Our interval here, it will be lower bound to infinity, and here minus infinity to the upper bound, right? I can sketch it like you can see. This is our x bar is here, and you can find this is lower bound is x bar minus e, right? And our interval, it will be this interval. The area of this interval is 90% or 95 or 99%. So the probability that mu belong to this interval will be 90%. And in this one, it is like x bar is here. This is our upper bound. It's x bar plus e, and our interval will be this one, right? From minus infinity to u, and the area here is 0.9. The second case, yeah, please wait a little bit because I want to summarize the last one, the last time, and I give you some review exercises. After that, I will open the quiz for you. So question number 2 is x here. It is normal mu sigma square, but sigma here is unknown. So what we have to use here, class? In this case, we use standard normal distribution. And for the second case, which distribution that we use here to estimate, class? Hmm? T, right? So E here, in the position of Z, you write T, alpha over 2. And what is the degree of freedom? DF, degree of freedom. What is that? Degree of freedom. Anyone remember?
N minus 1.
Okay, n minus 1. And to find this one, you use table. Okay, we don't have the other ways to find this value. T table. This one you can use calculator. And please remember that this number you can use table, Z table, or you can use calculator. But please round your answer to two decimal places. Please remember because it's the agreement. Okay, if you round it to three decimal places, so maybe the result for the confidence interval will be different. That's why please take note that for z alpha over 2 or z alpha, you have to round your answer to two decimal places. It means that we use z table, so you see that we have two decimal places only, right? So please take note. But for t, so we use round your answer to how many? Three. Okay, three decimal places. Please remember that, because this is the agreement so that we have the same answer in the examination, because you know that we have multiple choice problems, right? Okay, and here instead of sigma we use what? S over square root of n. As I told you, S here, this is the sample standard deviation, so square root of this number. Okay, taking square root of this number, or on your calculator it is Sx. And our interval, I forgot, anyone can record the screen, because my storage is out of memory, so I can so in Google Drive, that's why I can't record the lesson. Anyone can record for me, because you can send to your friends later. Maybe some of you uh, didn't attend the class. So anyone? Hello? Is there anyone that is recording the screen? No
Yeah,
one?
I'm recording.
Okay, okay, thank you. Yeah. Uh, and please send it to your friends, okay? Okay, a second, here the same formula. So mu belong to this interval where we just change it into this one. And E in this case it is T alpha over 2 and minus 1, okay, S over square root of n. The third case that we consider here, the third case, this is the case when x follow an arbitrary distribution, and sigma here it is unknown, or maybe it is known, we don't care. Okay, if it is unknown, so we use s. If it is known, so we use sigma. Okay, so but we have one condition here, is n is a large number. So using central limit theorem, we can approximate using the z, right, standard normal. That's why in this case we use z, right? Z alpha over 2 sigma rs. Okay, so in case that we have sigma, so we use sigma. If we don't have sigma, so we use s over square root of n. And yeah, so mu here belong to the interval x bar minus e to x bar plus e. So the condition of n here is that n is greater than or equals to 40. Maybe sometimes we use 30, but we often use 40, right? And here e, it is z alpha over 2, sorry, z alpha times s over square root of n. And similarly, lower bound is x bar minus e, upper bound is x bar plus e. And class, please take note. This one I already tell you, but I just repeat. That if it belong to case 2 and case 3, so it's two cases, so we have an agreement that we will use case 2. It means that we use T distribution instead of Z. Class, remember? So it means that if I give you a normal distribution and n is large, sigma here is unknown, so we still use 2. We don't use 3. We don't use Z distribution, but T distribution. Okay, remember? So please take note that if we have normal and sigma is unknown, so I don't care if n is large number or small number, we will use T distribution. Okay, and just one more. Number 4 is proportion. So we want to estimate proportion, population proportion, and n here is a large number. So we use like central limit theorem to approximate x, right? When x here is the number of elements that have property x, right? So E here, it equals to Z alpha over 2 because we use central limit theorem. That's why we approximate it by standard normal. And do you remember what is the formula here? What do we multiply? Square root of what? Anyone can tell me? What is that? Square root of what? Hmm? P1 minus P? No, not just P1 minus P. Something. Yes, over N. Okay, don't forget over N. And here E is Z alpha. Square root of P here, P hat, right? Because we don't have P, so we use P hat to estimate, right? So Z alpha, P hat, 1 minus P hat over N. Okay, and our confidence interval here is the interval of P, okay, or not of mu anymore. Here we estimate the proportion, so it will be P hat minus E to P hat plus E. And in this case, lower bound is P hat minus E. The upper bound is P hat plus E. And about the questions of the sample size, it means that if I give you E, so how can we find the sample size? And about the sample size, if for a given error, so N is greater than or equals to what? Class, please tell me. Mm? So from this equation, what can you find? Huh? From this equation, what do you have? Will be Z alpha over 2 over E, okay, total square times P hat 1 minus P hat. That's right. Okay, but and you have to write it up, okay, round up. But please take note, class, please take note. In case that you have to define the sample size before before doing the experiment, it means that if P hat is unknown, it means that you haven't done any experiments. You don't have the estimate of P. You just want to sample size. So what you have to do to define the sample size? Mm. So Class, how? If we don't have p hat here, class, how can we define the sample size if we don't have p hat? So we choose p hat to be what? Who remember? I remember that yes, it's 0.5. Okay. Of course, in this case, the sample size is much greater than, yeah, it will be much greater than this number. But yeah, if we don't know, so we just choose to be over 5. Okay, because we haven't done any experiments, so we have to choose to be over 5. You see, because um, if you use Cauchy inequality, so p hat 1 minus p hat always less than or equals to p hat plus 1 minus p hat over 2 total square, right? That's why it equals to 1/2 square. And the equality happens when p hat equals to 0.5. You see? So if I choose to be 0.5, so it's the maximum number, right, already. Yeah, it's much greater than this number. But yeah, if we don't have p hat, so we have to use this way to estimate the sample size. Okay, anyone has questions? No? So I already summarized the content for chapter 4. Now I uh, give you some problems, and um, so please wait. I find some problems here. Um, oh, I remember that I have exercise 5. Where is it? Please wait, because I remember that I have uh, 5. Here, I found it. So I will upload a file in Bigel, and you have to solve these problems. Download this file. Exercises for chapter 4. Okay, I already uploaded. So we have some exercises for chapter 4. 8 exercises. Please solve them all, and after that, you have to solve a quiz. The last quiz. No, sorry, not the last one. Have you seen this file in BKM? Yes or no? Here, this file. I will upload it in the theory class also. Have you seen the file? Yes? Okay. Yeah. So please solve these 8 problems. Okay, have you finished the number 1, exercise 1? Yes or no? Did you understand what it means? Huh? Guys, so which case do we have here? 1, 2, 3, 4. Huh? Guys, which case? 1, 2, 3, 4. Yes, number 4, right? Because here we just have what we have, the number of so the sample size, and we have the number of fish that have a kind of property X, right? Yeah. So do you understand the problem here? It means that in a lake we have fishes, but we don't know what is the number of fish in our lake, right? So what we have to do? We caught 300 fish. So this is 300. It's just a sample, right? We take from the population. So this is sample size. And we made a seal. Sorry, it's not a sample size. We just caught 300 fish, and we drop them back into the lake. Right, we drop them back. So we made a seal. So like on a fish, I made some kind, right, of seal to know that, yeah, this fish we caught, and then we return them back to the lake. And after a period of time, right, so of course these fish, of course they don't stay in the opposition, right? So here are the fishes that we mark already, and the other fish. And what we have to do, we randomly take 400. So now I take a sample. This is my sample, right? And the sample size here, it is 400, right? I take some fishes, 400 fishes from this lake, and in which we found that 60 that have been marked. So the number of fishes that have been marked in my sample, it is what? This number, it is 60. Class, understand the idea here? Yes or no? Okay. So what is the proportion of fish that have been marked in my sample? So what is the sample proportion? So the number of fish, so the proportion of fishes that have been marked in my sample, class, I denoted by p hat. What is it? Yeah, it will be 60 over 400, right? This is my estimator of the population, and population proportion. And here, if we have the number of fishes in our lake is n, and here it is 300. So what is the population proportion, class? The real proportion of fish that have been marked in my lake, what is it? What is p?
300 over n.
Yes, 300 over n, right? I don't know p, right? But we can use p hat to estimate p. You see? So if we have p hat, so now can you find n? Yes or no? Yes or no?
So n will be also in an interval, right?
Yes. Okay, interval. But if I just use one value to estimate, like the point estimate, just one value, it means that I use p hat to estimate p. So n hat, it will be what? N hat, it will be 300 over p hat, right? So this is my estimator, but it's just one value. Now I want to to find like number of fishes in the tank with 96% confidence. It means that I want to give a range for n, so that the probability that my real number belong to this interval it equals to 0.96. What it means is that I have to construct the interval of p, right? From the interval of p, I can find the interval of n, for n, the range for n. Understand the idea, class? Yes or no? Class, yes or no? Hmm? Class, understand? No? Okay. I explain it again. Of course, I don't know the number, the exact number of fish in my lake, right? I don't know. So it's n. I just know it's n. So what is the idea? We take 300 fish and we mark them. So the proportion of fish that have been marked in our lake is 300 over n. Agree, class? Yes or no? So in n,
Yes.
okay, in n fish we mark 300. So the proportion that of fishes that have been marked is 300 over n. Yes. Now I don't know p, right? I want to estimate p. What I have to do? I take a sample. Okay, I return these fish into the lake already, and I take a sample of size 400, sorry, 400, and I count the number of fish that have been marked in my sample. So the sample proportion, okay, it's not a population, it's not p, it's just the proportion for my sample. It will be what? 60 over 400. Pass, agree or not? Yes or no? Okay. And we don't know p, so we use p hat to estimate p. So suppose that if I use p hat to estimate p, so I can estimate n using what? N it is 300 over p, right? But I don't have p, so I use p hat. That's why in this case I will have n hat. Understood? Yes. But if I estimate like this is just one value, right? And you know that if we just give an estimate, so we have high probability that it is wrong, right? Because yeah, we just have one value. So instead of one value, I want to give a range, so an interval for n. So how can I find the interval for n? I will find the interval for p, and then 300 over p, it will be n, that's right. So if I have a range for p, so I will have a range for n. Understood? Yes. Okay, so now please find 96% confidence interval. So I want to find 96% confidence interval on the population proportion. So I want to find this interval. It's case 4, right? And after that, we have to find the range for n, please. So now you just have to apply the formula. What is E? What is the interval? So we have some information that n, it is 400, it's a sample size. P hat, it is 0.15. No, over 15, 60 over 4, yeah, over 15. Right? So alpha, what is alpha, class? 96% confidence interval. So what is alpha? 0.04. So we have z alpha over 2, please. Tell me, what is z alpha over 2? Yeah, so you round your answer to 2 decimal. Yes, it's 2.05. Class, please. If you have the answer is 2.09054, so please round answer to 2 decimal places. It means that 2.04. Don't use 2.0, sorry, 05. Don't use 2.06 because as I told you, we have an agreement that round your answer to the nearest number, 2 decimal places. Okay, yes. So what is E? It is Z alpha over 2 square root of P hat 1 minus P hat over N. So please tell me your answer. And 96, okay, approximate. Oh boys, round your answer to 4 decimal places. Anh, Kỳ Anh.
Wait, I thought it's just 3. Wait, so this one must be 4, right?
Which one is 4? I don't
The
understand what you mean.
I thought it just round to 3 decimal.
No, 4 decimal places. I said for Z value. So you round it to 2 decimal places. For T value, you round it to 3 decimal places. For general numbers mean that for interval, for result, for your score. So for any other cases, so round to 4 decimal places. Okay. So it's 0.0366. Got it? Okay, Anh?
Yes, yes.
Okay, so 96% confidence interval on the proportion. It will be what? P hat minus E and P hat plus E, right? Now I can give 96% confidence interval on N here is the number of fish in our lake. So what is that, class? You take what? What is N? N is 300 over P, right? So what is the lower bound of N? Is 300 over what? Hmm? What is the lower bound? Okay, P hat plus E minus E or plus E, class? Yeah, plus or minus E?
Plus.
Yeah, because if the denominator is great, so our number will be small, right? Yeah, so it will be O. So you have to find it. Please, P hat plus E, P hat minus E. Tell me your answer is this one. So please.
If n is sometimes some number that have 0.7, we round up, right?
Yeah. For the answer here, you don't have to write. Of course, you can route it to the nearest integer because you know that confidence interval is just the estimate, right? So we don't need to be it be greater than or equals to less than. Yeah, just route to the nearest integer. nearest integer. Or if you don't want to route it, so let it be. It's okay. But here, don't route it, okay? Because you know that you just route it at the end in the final step. So please use a long format here, like in a big questions. For example, in the examination, I will have a big questions, and in each questions I will have sub questions A, B, C, D, right? And first here I want you to find the error. So yeah, so here you route it. But in the question B, if I want you to find a confidence interval on n, okay, so here I use this formula, and here E don't route it, so you have to use the long format here instead of 0.30366. Understand what I mean? It means that we just round in the final step. We don't round between steps. So in the question A, you still write 0.0366. But to find the answer in the question B, you have to use the long format. Okay, so it's 1607.7 and 2645.5. Class, do you have the same answer here? Okay, that's it. Yeah, it's the number one. We show it together already. So the others, please show by yourselves. Because the problem one, I know that this has a new idea here, right? So I explain it to you. But the others, I think that you already know how to show them. So the other, please show them by yourselves.
Ô, coi như cái câu 2 như nó thiếu hay sao cô? Mấy cái giá trị sample như nó không có đủ 24 cái.
Let me check. Uh, hmm. Oh, because it's too long. That's why it cut it here. Yeah, it's my mistake. So, what is the sample size here? Let's just use the last number is 25. Okay, so 14, right? Is it? Okay, 14. Okay, please fix it because, yeah, I copy from some, I don't remember, maybe in one book, and when I enter, so it's too long and I didn't mention, so it cut it here, so it's lost information. So 14, not 24. So which case here, class? 1, 2, 3, 4. Which case? Hmm? Class, which case do we use here? Yes, case 2. That's right. Mm. Yeah, so please show it. No. We have to estimate, yeah, the mean diameter. So it means that x bar. So it means that we find a 95% confidence interval. And the mean diameter is x, right? Mean diameter is mean that x bar, sorry, mu, right? We want to estimate mu, and 95% confidence mean that the interval. And if we don't say anything, it means that two-sided. Okay, Khôi. So what is given here? Diameter is normally distributed, right? And we randomly choose 24 machine as is produced by this type of length, the following results. So here, look at the table that I summarize here. So it's follow normal. It means that first or the second case, right? Z or T. But here sigma, is it given, Khôi? Sigma. No, it means at which case? Yes, T table. Okay, sigma is known, so we use Z. Unknown, so we use T. That's it. So E here is T alpha over 2, N minus 1, but here is not 24, but 14, okay, because it's cut already. So 14. S over square root of N. So class, please, first step, find X bar and S for me. Here, N is 14. Okay. You have to enter the numbers to the calculator and find X bar S. Tell me. Okay, 25.61. No, please round your answer to 4 decimal places. Hang. 25.60. What? Hang. Okay, 6071. And so why you have different number here? S or sigma? Please use SX, don't use sigma X, okay? Hang. It's not sigma. No. It's S. It's the standard, but standard deviation, but adjusted already. So we divide by N minus 1, not N. Or you can use your calculator to find it, but you use S, but not sigma, okay? And see your mistake? Okay, thank you. Yeah. And we apply case 2. Two-sided, because if it's not mentioned lower or upper confidence bound, it means that two-sided. Okay, so E here equals to T alpha over 2. So N minus 1 is 13, but you have to find alpha, and T alpha over 2 N minus 1. So what is alpha here, class? Alpha is 95% confidence. So alpha is 0 point what? Khoi, because maybe it's the third case when we have large sample. So you're late today, right, Khoi? Because I just summarized all cases. Khoi, you are late, right? Yes, the last case, the third case is mean that here X is not given the distribution, but N is a large number. So we use central limit theorem. And then we use Z, we don't use T, because central limit theorem approximates the variable X bar minus mu over sigma over S over square root of N by the standard normal. That's why we use Z. But in case that N is a large number. But in this case, even N is a large number. For example, N is 100. We still use T because we have agreement that is T. But here is not large, right? It's just 14. It's not a large number. But I say that even is a big number, like 100. But we still use T distribution. Okay? Because this is our agreement. So what is alpha here, class? 95%. Khoi, you got it? You understand? Okay. Yeah. Alpha here, what is that? 95% confidence. So alpha is 0.05, right? So please find T 0.025 and N minus 1 is 13. So please tell me the T value. Find in the T table. Okay, 1.771. Thank you. Class, do you have the same number here? Yes. And after that, you have E, right? E is T alpha over 2n minus 1 as over square root of n. And then the confidence interval is x bar minus E and x bar plus E is the upper bound. Oh, Phước and Bảo, you have different answers, so I have to find it. T 13, this is 13, you see, and 0.025, so it's 2.16. So you found your mistake, Huy, about, because alpha is 0.05, but you have to find z alpha over t alpha over 2 is not t alpha. Bảo, got it? You see your mistake? Bảo, see it? This is alpha over 2 because it's two-sided. So it is 2.16. Okay, after that, please find error. Error here is t times s over square root of n. And then you can find, or you don't have to find e, you just write the lower bound and upper bound for me. Okay, have you found the lower bound and upper bound, please? Right, so I can check the answer. Okay, today we study till 10, and then I'll open a quiz for you. You know that we have the last quiz. I give you 1 hour, and I won't open it again. Okay, got it? So it's, yeah, 24.789 and 26.4252. Okay, thank you. 89, right? This is 89. Okay. Class, you have the same answer with Anh Tuấn and Kỳ Anh, right? Check the answer again. Okay, yeah. Next problem. Problem 3 and 4. Can you tell me which case do we have for question 3? Which case, dear? Problem 3. Which case? Yes, case 1. That's right. Because when you see the normal distribution, it means that 1 or 2. Okay? Sigma here is given. So it's case 1. Yes. Okay, so look at the problem 4. Which case here? We define the case first and then you continue to solve. So which case here? It is normally distributed. Sigma here is known or unknown. So which case? Mm? We use, yeah, so we use Z or T distribution, Z table or T table. Z or T here, case 2, it means that we use T, okay. Problem 5, which case here? So, proportion. So when you see the proportion, so it is 4. Yes, case 4. Problem 6, which case? Yes, it's case 4. It's similar to the first problem about the fish in the lake. Okay, we estimate the proportion first, and after that we estimate the number of voters. Okay, yeah, it's correct. It's case 4. Problem 7, which case? Number 7. Yes, it's case 3. That's right. Because here, is it given that we have normal or not? No, right? Normality assumption we don't have, right? Distribution we don't know. But sigma here is unknown. But what? We have 100 stores. So the sample size here is a large number. So it's case 3, right? Central limit theorem, we use Z. Okay, so I summarize here. The question 3, it is case 1, right? 3 is case 1, so we use Z. Number 4, we have case 2, so we use T. Number 5 is proportion, so case 4, so we use Z also. Number 6, so it's also case 4, so we use Z table. Number 7 is case 3. We use Z again. And the last one, question 8, which case here? So when you see the proportion, so of course it's case 4, right? And you use Z. So I summarize here the case for the problem from 3 to 8. Now just apply the formula, right? Yeah, so now I will stop sharing the screen because no, T table. Yeah, so I show it. So if you don't have 35, so you round it to the okay. So let me see. You can choose one of these two numbers. So what is alpha here, Phước? In question 4, what is alpha? Two-sided, right? So 0.025 here. 0.025, this column. and 35 is between these two numbers. So in this case, you can use one of these two numbers. It's okay. So you can choose 2 point. Of course, in this case, we will have error because we don't have the exact value, right? You can use 2.042 or you can choose 2.021. Or in this special case, you can find the average value of these two numbers. It's okay. So you take 2.042 plus 2.021 and you divide by 2. Phước, you got it? So in this case, we accept error. Yeah, because in the table it's not given. Yeah. So I stopped sharing the screen because I have to open the quiz for you. So please solve the problem by yourself and I just ask for the answer. So because we can't solve all problems, so I choose to solve problem 3, problem 4, and problem 7. Okay, so problem 3, 4, and 7, so that we consider case 1, or 3 and 7. Okay, so now please solve number 3 and number 7. The others you can show them later because we defined the case already. You have the formula already, so just practice with one more is case problem 3 and problem 7. After that you have to solve the quiz. Ủa, con bấm robot chạy hả đâu? Sao tự chạy? Yes, Ủa Bon, con làm xong bài tập chưa? Như tuần sau cô có giao mà, cô có gửi Zalo cho mẹ hả? Chắc không? Nó sắp thi mà phải vợ nhà Bon.
Cô ơi.
Ui chết, nãy giờ cô không có test mấy chồng mấy đứa. Sorry.
Cô ơi, cái quiz cô để nhầm thời gian due time ấy. Cô để 12 giờ sáng hôm nay.
Đúng rồi, 12 giờ hôm nay đúng mà.
Không, ý là 12 AM tức là 0 giờ sáng.
Ôi chết rồi, cô để 12 AM mà từ để cô xịn lại, cô tưởng để cô kiểm tra, cô check lại.
Dạ.
Vâng. Nãy giờ cô không có tắt mic. Sorry. Have you finished the problem 3 and 7? Yes or no? Have you finished?
Ủa, có cái câu 3 xem maximum error là ý nói là E hay là X cộng E gì vậy cô?
Maximum error, so error. You see, error is not the upper bound. Upper bound is the highest value. It's not the maximum error. Understand? Yes. Okay, I check. Where's my file? Is it this one? So number 3, right? Um, what maximum error? I don't say that it is the maximum value, right? Maximum estimate value. No, it's not the upper bound. I mean maximum error. So it's E. Got it? Hmm? Yes. Understand?
Yes.
Mm-hmm. Yeah. Uh, so problem 3. Problem 3. I write down here. Problem 3. So x bar is 124.5. Sigma here is given is 2.5, and here is 25, right? Alpha here is 0.05 because 95% confidence. So for the first problem, we find z alpha over 2, right? And after that, we find error. It is the z alpha over 2, sigma over square root of n, right? And our interval is will be x bar minus e to x bar plus e. So what is z alpha over 2, class? What is z alpha over 2? Okay, 1.96. So what is e? 0.95, 98. Are you sure? 5. Yes, oh, 5. Right. So x bar minus e. So you subtract x bar by e. So what do you have? Lower bound and upper bound. Very simple, right? So you take this number x bar minus e. Okay, so it's 123.52 to 125.48. Okay, thank you. And question B, if you want the length of the 95% confidence interval not to exceed 0.4, how many products should be weighted? So this is our interval. And what is the length? Class, the length of this interval, it will be what?
2E, right?
Yeah, 2e. It is 0.4, right? So it's mean that less than or equals to 0.4 and not to not exceed, right? So e is less than or equals to 0.2. So n here is greater than or equals to what? How many products mean that you have to change the sample size, and is greater than or equals to z alpha over 2 sigma over e and total square. See it? And what is your value? Okay, 600 and 0.25 is mean that you choose n to be 601. You have to round it up. Okay. Question C, if people use a sample of size 40, so n here is 40. To find a confidence interval with the maximum error 1 gram. So it means that here alpha is unknown, right? We don't know. But we know that the maximum error is 1. So I want to find alpha. Understand? So to find alpha, what you have? You have, this is the relation, right? So to find alpha, you have to find Z alpha over 2. So what is Z alpha over 2 here, class? Z alpha over 2, it will be E over sigma, right, times square root of n. Class, see it? So from this equation, you can find Z alpha over 2. See it? Class, can you see it?
Yes.
Okay, so please tell me what is the value. E here is 1, square root of 40. And sigma here it is what? 2.5. So please tell me the value Z alpha over 2. Okay, 2.5298. Okay, so if you have Z alpha over 2, so tell me what is alpha over 2. You can use table to find it. It mean that you have to find like this is the value Z 2.53, right? 2.53, and then you have to find phi of you know what is Z alpha over 2? Got it? What is Z alpha over 2? This is the point Z alpha over 2. So this area, it is alpha over 2. It means that phi of Z alpha over 2, this area, it equals to what? 1 minus alpha over 2. Okay? So you have this value, and this is the standard normal. So mu here is 0, sigma is 1. Please find phi CDF. This area. Use your calculator or you can use table, anything. Please find what is phi of this value. Do you know how to find it? Okay, 0.9943, right? Approximate 0.9943. It means that alpha over 2 is approximate 0.0057. So alpha is approximate what? 0.0104. You see? So confidence level. What is the confidence level, class? If alpha is 0.0104, so the confidence level, it is 100% minus 1.04%. So it's about 98.96% confidence. Do you understand? Yes or no? Yeah. Now problem. Yeah, it's just like the inverse problem, right? Inverse problem. Number 7 is case 3, right? So here I give you the value, and you know how to find x bar and s in this case, right? No, it's not alpha over 2. Fool. You're wrong. What is phi? Phi is the probability that z is less than or equals to z alpha over 2. So if z alpha over 2 is 1.53, so you have to use, if you use your calculator to find the area, so the area it equals to what? Area, so you write mu here is 0, sigma here is 1 because it's the standard normal, right? And the value, the lower bound is minus infinity, lower bound, and the upper bound is 2.5298. It is z alpha over 2. So you find the area from minus infinity to this point. So this area is phi. It's the CDF. cumulative distribution function. The value of this one is this probability. So you find minus infinity, the integral from minus infinity to this point z alpha over 2. Understand, Phước? So the value you tell me is not alpha over 2. It is 1 minus alpha over 2. Alpha over 2 is the upper tail here. You see this area. Phước, if you want to use alpha over 2 here, so alpha over 2 is will be the integral from z alpha over 2 to infinity. It's okay. It means that in your calculator, you write mu is 0, sigma here is 1, and lower bound, it is 2.5298 is z alpha over 2. And the upper bound, you use infinity, it means that you choose a large number. So alpha over 2 is this area, and this area is the integral from z alpha over 2 to infinity. Okay, if you write from minus infinity to z alpha over 2, so it's 1 minus alpha over 2. Okay, so if you want to directly find alpha over 2, so you can apply this formula from z alpha over 2 to infinity is the upper term. Okay, class got it, right? Yeah. Next, the problem 7 here, we have case 3, right? Case 3. We use central limit theorem to approximate in case that n here, I say it again, x here, we don't know the kind of distribution. We don't know. We don't know if it's Poisson or binomial or exponential. We don't care. But sigma here is unknown. Yeah, unknown. But n is a large number. And here is the table for n here. Here we don't list our own value because some of them are equal. That's why here we have the first value is the price, and the number of stars is the frequency. Frequencies mean that there are 6 stars that have the same price. Okay, 7 stars will have this price, 12 with this one, and the total number of stars here is 100. In your calculator, you have a function, I don't know. Last time, I remember that I showed you last time, but because I don't have calculator, I never use calculator. So don't ask me. I don't remember. Ask your friend how to enter the data. Here, the first column is the price, and the second one is the frequency. You know how to enter this kind of table, right? Class, I don't know. You can search in YouTube. Okay. I don't know which mode. Yeah. And after that, please tell me what is X bar and what is S. I just care about X bar and S. I don't care about the way. You have to find it by yourself, but I definitely know that. It certainly know that it has, but I don't know. Don't ask me. So tell me, what is X bar and what is S? For this table? Okay. So have you round it or you don't round it, right, boy? Is the exact value, right? Because n here, okay. And what is S? Okay, 1.89. Thank you. So here 95% confidence interval for the mean, right? The average price mean that the mean. So I think that you can show it by yourself, right? Because it's exactly the same. Alpha here is 0.03, so you can find z alpha over 2. So error here is z alpha over 2 s over square root of n. And the 97% confidence interval is x bar minus e to x bar plus e. You can show it, right? Because someone asked me about a problem 7, so I don't know. I have to show it, but I don't think that there is anything new here. No, you don't have to show it, right? Has? Can we skip it? Yes. Problem A. Has? Okay. Yeah. Question B. If we want the estimation error not to exceed 0.3 and the reliability of the estimate is 99%, at least how many stores need to be investigated? So here we have that the error is less than equals to 0.3, right? And alpha here is 0.01. So you can find z alpha over 2. You have to find n, right? At least how many stores. So n is greater than or equals to what? E, it is z alpha over 2 s over square root of n, right? So here we don't have sigma, but you can use s to estimate. So greater than or equals to z alpha over 2 over e times s, right? Or no, s here, n square, and round it up. Anyone has questions here? No? Yes? Can we skip it? Because it's exactly the same, but just we replace sigma by s. Class agree? Class, do you agree with that? Here all value we have, right? We have z, we have e, we have s. Here, alpha is 0.001 koi. So I have to find the new z alpha over 2. Yeah. Okay. Okay, we just use s to estimate sigma, that's all. Agree, Khôi? Yes. And now we show the last problem. Estimate the percentage of stores selling below the recommended retail price by the company with 98% confidence. So what is meant? The recommended retail price by the company is the sample mean price. So what is the sample mean? What is the sample mean here, class? Class, what is the sample mean? It is 86.76, right? So in 100 stores, can you tell me, this is n, it is 100 store. Please tell me how many store that sell below with the price below this sample mean. How many? So 86 here, right? It's between 86 and 87. So please tell me how many store that sell products below this one is 40. Class, do you have the same answer here? 40? Class? Okay. So what is the proportion of store that sell below this price? Is 40 over 100 and it's 40%. You see? But it's just the estimates of the exact proportion. Understood? Yes? Class, understand? Yes or no? Okay, so the question C, what is it? This is the confidence interval of the proportion. Understand? So it's case 4. With the confidence level in 98%, it means that alpha is 0.03. Oh, sorry, 0.02. Class, understand? Yes or no? Yes or no, please? Yes or no, class? Okay, so you have p hat is 40%, and here is 100 star. P hat is the sample proportion. You want to estimate, so we use E. What is E? E here is Z alpha over 2, case 4. Okay, case 4 is for proportion. Square root of P hat 1 minus P hat over N. And after that is 98% confidence interval on the mean. So P belong to the interval P hat minus E to P hat plus E. Understood? Yeah. So in question 7 is we combine two cases here, is case 3 and case 4. Let's got it. Can you show it by yourself? Right, I write on formula here already, so now you just have to find it and substitute. So please, what is Z alpha over 2? If alpha is 0.02, so alpha over 2 is 0.01. So can you tell me what is Z alpha over 2, class? Please find it right now. Alpha is 0.02. So Z alpha over 2, what is it? Okay, 2.32. And please find the error. Here, P hat is 0.4, 40%. So 1 minus P hat is 60, 0.6. You divide it by 100. So square root, what is E? One is 0.4. Okay. Okay, 0.1137. So P hat is 0.4 and you subtract it by this number. So what do you have? 0.3682, right? And 0.5137. Got it? Yes? Okay, so if you don't have any questions, so you can solve the quiz. I will close the quiz at 12. So I give you 70 minutes, but because I give you second chance, so that's why you have more time. But I will close uh, the test at 12. So you can solve it right now.
Cô ơi,
Yes.
cho con hỏi là lớp mình khi nào mới nộp bài tập lớn vậy cô?
So this way. How many? We have final at the beginning of June, right?
Dạ đúng rồi cô.
Okay. So I think that so how many weeks do you need for the project? After 2 weeks, is it okay? Or 3? 3 weeks. Okay. So 1 week is 30. 2 weeks 7. So at 14 of May to 16 of May. So in the middle of May, I will send you email. Okay, I will open the in BKL. I open the Please wait. The forum. And you have to submit your reports there. Please, where we have here. Where is it? Forum. Here. So we have reports of the class TTO1. Please submit your reports in this topic. Each group send me just one version. Okay, if you want to update it, so please reply in your topic. Okay, please don't open a new topic because it's difficult for me to follow. Do you understand what I mean? One PDF 5. Okay, one PDF 5. Don't send me in the other format because sometimes it has error, so I can't read in my Mac. So that's why just use PDF file. What's the problem? Time's out. Strange.
Teacher, do we need to present the report or just submit
Of
it?
course. No, I will ask for your reports. Here, reports.
What do you mean?
I means that you have to present it, and I will ask some questions. I read
When will we present?
So I tell you that it's between 14 and 16 of May. So we may have online reports, or maybe if I can find a room, but I'm not sure because maybe at that time I don't know if they give us the room anymore. I don't know. If I can't find a room, I hope that we will have offline report. But if I can't find a room, so we will have online. And you know that I will randomly choose a member in a group to ask. So all of you have to read and understand what's in the report, because you can say that no, I don't do this part, I do the other one, so I can't answer your question. It's okay, so you will have minus, I don't care. Okay, because it's your report, you have to show all of you, all students in one group have to understand, okay, what is in the report. So don't tell me that I do this part, I don't do this one. No. Okay, if you I will ask, maybe I will ask all of you, because we have new rule for the reports. Maybe I will ask 5 students own student in the group, and if you can't answer it, okay, 0. So if you submit the reports so in the correct form, so you will have 5 correct form, and of course is so it in proper form, like you well understand what you mean in the report. And yeah, so maximum score for the report is 5, and the other 5 points I will ask 5 students, just short, maybe short question, if you can understand and answer my questions. Yeah, so I asked the other one, so 5 questions for five score for that part, and 5 score for 5 points for the reports. Understand? Yes. Please send me one PDF. Okay, so not topics, but reports. TTO3. Okay. Anyone has questions? Class, do you understand? Yes? So here, please submit the reports here and submit in the correct class, because if you submit in the other classes, so I can find your report. So please submit in the correct class, and just for one group, just please upload one file. Okay, just one file. Any other questions? No? If not, so please show the quiz and we stop here. Yeah, bye all.
Cô ơi, chỉnh lại thời gian của quiz nha cô.
Cô chỉnh rồi mà, xuống thành 12 giờ trưa rồi mà.
Dạ, cảm ơn cô.
Bye.